You know, it's pretty straightforward to compile a Rust application into WebAssembly format that would allow you to import that logic into a React application. It's actually really straightforward and simple. You essentially need to run it on your system, Node.js with npm, and then have Rust installed, of course, and then cargo install wasm-pack. You'll be able to use wasm-pack to build a Rust library as wasm, which you can easily import. So you just create the Rust library using cargo, and then you compile using the wasm-pack program. Yeah, there's a hyphen right here. It's like, usually you don't see hyphens when you execute, a program. In this case, there is a hyphen. Then you would set up your React app to import the WebAssembly module. There's some significant advantages to using WebAssembly instead of JavaScript inside of your web application, whether you're building React or Vue or Svelte or any other kind of web front end. Using WebAssembly is going to bring a lot of advantages. The first off, of course, is speed. It's going to be a lot faster, and compilers can optimize for a better code execution efficiency. This is really powerful because even if you're using TypeScript or JavaScript, which are pretty much the only options that you have, they cannot be as fast as compiled code. You also have the ability to import other languages like Rust, C, and C++, which gives you a lot more library support for all the different libraries out there, and you get better security from a perspective of sandboxing, right? Because you can only really communicate with the binary directly through a message passing system and up to the browser space and to the execution space, so it's sandboxed. And you also get cross-platform, which allows you to then import some code that you might have built and written for other platforms. Now you can import that into your web application as well. So now you can start writing applications that you need to deploy across all sorts of applications, which is really powerful. And going beyond the browser, you can use it in non-browser environments such as server-side applications, which is really beneficial because you could also import this module into your Node.js application and do the same thing that you would do with a browser inside your Node.js application and get the best of both worlds. And then if you needed to, you might have some Python logic, or you might have some Java over here, or some PHP. It doesn't matter. You'll be able to have a unified code base by using WebAssembly. There are some really powerful use cases for using WebAssembly or WASM inside of a web browser, for example, or any other application. In a web browser case, it's really powerful from a game development perspective because now you'll be able to execute code in a high performance environment. That's a lot faster than using JavaScript as a render loop. I mean, that's just a significant win there. Obviously, cryptography is another way from a security perspective, sure. Also, from a high precision perspective, JavaScript does not give you the maximum precision capability. With other languages, though, you can have as much precision as you need. And video image processing can be really powerful if you take advantage of building images and frames inside of WebAssembly binaries rather than having it done in JavaScript world. Also, scientific simulations requires heavy computation, and you get the benefit of the efficiency through WebAssembly. Porting existing applications is also a huge use case where you have a lot of logic you've already built in another application that's compiled. You can target WebAssembly and then import that into other languages that support it, such as the web browser, Node.js, and a lot of other environments as well. In a few simple steps, we can convert our Rust library into a WASM library that you can use to import into a web browser app like a ReactJS app, or into Node.js as a runtime on a server. It's really straightforward. Check this out. We start off simply by following these instructions. We'll create a brand new Rust app called with a cargo new hello wasm. Let's go ahead and run that command here really quick. And oh, that was fast. So we've got ourselves a brand new library here. So in our source file, we simply have two files. That's it. Cargo toml library.rs. All right, that's really easy. So then we can open up our cargo toml, and then we want to grab these additional lines here for our cargo toml, and then we will pull those in. So we'll just copy paste those, get everything in the right spot. All right, there we go. Really easy, simple. All right, so we're getting used create type. It's going to be a C dynamic library, so cdylib, and then we're going to import wasm-bin-digen. bin-digen. That's going to allow us to create the bindings for wasm. And with cdylib. All right, here we go. So that's done. Now we should be able to, I believe, edit our lib file. So that way it has, let's get rid of the test. We don't need that. We also don't need this either. So let's get rid of this. All right, now all we need to do is import wasm-bidden, and then we're going to annotate a function called greet, which is going to return hello world. Really straightforward and simple. There we go. That's it. That's all we have to do. We'll close that. And then we should just be able to build the application using, if you don't have wasm-pack installed yet, make sure to go ahead and install that, because this is going to be a way to build a target for the web. And then we'll run that, and it will start building, and it will make sure to import all the things it needs to import, rebuild all the libraries, and then compile specifically for WASM with the target of WASM. And there we go, it's all done. It's really fast and simple. We were able to create a WASM library in Rust just so quick here. So all the files you need are going to be in this new package directory. Here you go. Here's all the files you need. Your hello WASM, the actual WASM file itself, and even there's a TypeScript. That's interesting. I'm kind of curious just to see. We're already done here. We already have the package that we need, but I'm curious to see what's inside the hello WASM. .js file is probably going to allow us to import some things. Oh wow, okay. Oh, it's a nice little boilerplate stuff that we need. Okay, yeah, that makes a lot of sense. Okay. Importing a WebAssembly file into your ReactJS app is going to actually be pretty straightforward, somewhat straightforward. It's going to require a few little steps here. What we're going to do is we're going to walk through a quick little tutorial. We're going to create a new ReactJS app from scratch, and then we're going to copy the WASM file into our source directory. Then we will import it into our React app. Let's start off by creating a React app just as a really simple hello world for WASM. All right, I pasted that in. Of course, npx npm is going to take a little bit to install this. This is always a pretty time-consuming step here. All right, it's finally finished. So now we go to the next step where we copy from a WebAssembly compiled Rust application, and we copy the package folder directory that was created with Webpack. wasm-pack, and then copy that to the ReactJS source folder as the folder name wasm. So actually pretty straightforward. Let's do that really quick here. So we'll copy cp hello wasm package folder to hello wasm react, and then the source file, and then we'll do it as wasm. So that should give us, oh, we got to have that -r. There we go. All right, so we've got all of our files that we need here for the next step. We also need a bootstrap loader for the WASM itself, so we can create this new file here, WASM loader, and then we want to just simply copy and paste the WASM loader straightforward, which is just going to import asynchronously our WASM file. And here's that. It's really straightforward. I mean, we probably don't need to create a separate file for this, but we will in this case. And then we're going to update our app.js file with all of this code here, which we will copy and paste this really quick. All right, here's our app.js file, normal React use effect use state. We import our WASM loader, which we created a separate function for, though I suppose we don't necessarily need to have a completely separate file for it, although it is nice because we'll use it more than once, right? So we'll want to make sure that's reusable. And then we have our use effect, and then we have some state here, our message. We will pull in the WASM module itself, which gives us access to that greet function that we wrote in Rust, and it was compiled into the WASM binary. And then we call the greet function, and we set the message. There we go. It's actually, that's it. That's all it is. And we have our, of course, our greet WASM function here. We call that so that way the state gets changed. And then it renders the message in the React app. So all we have to do, I believe, is say npm start, and we should be good to go. All right, here we go. Booting up the app. Hopefully it works. We'll see if it does. And there we go. Success. It worked. We got our hello world. This came from the WASM binary that we compiled in Rust. And so now you've imported code that has been executed in a binary format that's going to be giving you a lot better code execution environment from performance perspective. That is amazing, and it's running in React. It's all very straightforward and simple from that perspective. It didn't take many steps or much time, and now you have the power to import any kind of compiled language that can compile to WASM into your React application.